Welcome to Olympiad Math for Year 3. This is Lesson 23, we'll learn perimeter and area of rectangles and squares. First, we need to master common techniques and general methods for calculating the perimeter and area of rectangles and squares, then we will apply the concept and methods of transformation. Please pause the video and memorize the following contents. For basic rectangular and square figures, we can directly apply the formulas to determine their perimeter and area. For irregular or more complex geometric shapes, we can use the mathematical idea of transformation, dividing and rearranging them into basic shapes. By converting the given figure into rectangles and squares, we can then apply the standard formulas to solve for the perimeter and area. Transformation is a key mathematical strategy that requires identifying both the changing and invariant properties. Although the shape may change during transformation, its perimeter and area must remain unchanged. Therefore, it is crucial not to overlook any segment lengths or areas during the process. The goal of transformation is to convert a complex shape into one where the perimeter or area can be easily determined. Example 1, as shown in the figure, shape ABEFGD is formed by combining rectangle ABCD and square CEFG. The segment lengths are given in the diagram. Find the perimeter and area of ABEFGD. We can solve this problem via two methods. Method 1, if we determine the width of the rectangle and the side length of the square, we can find the perimeter and area of ABEFGD. The side length of square CEFG is GC equals DC minus DG equals AB minus DG equals 10 minus 4 equals 6 centimeters. The width of rectangle ABCD is B minus CE equals 10 minus 6 equals 4 centimeters. Thus, we can find the perimeter and area of ABEFGD. Method 2, by shifting segments GF and DG outward, we obtain a new shape ABEG'. Since GF equals DG', the perimeter of ABEG' is the same as that of ABEFGD. Since AB equals BE equals 10 cm, and angle B is a right angle, shape ABEG' is a square with a side length of 10 cm. Thus, we can find the perimeter and area of ABEFGD. The answer is the perimeter of ABEFGD is 40 cm, and its area is 76 square centimeters. Method 1 applies basic formulas for perimeter and area, requiring the length and width of the rectangle and the side length of the square. Method 2 uses transformation, converting a complex shape into a basic one. The perimeter remains unchanged, while extra area is added and must be subtracted in the calculation. Example 2, two identical rectangles, each measuring 9 cm in length and 5 cm in width, are overlapped as shown in the diagram. Find the perimeter and area of the resulting shape. The perimeter of the given shape is equal to the perimeter of a square with a side length of 9 cm, which is 36 9 cm for the area. The two rectangles overlap in a square region with a side length of 5 9 cm. We can find the total area in two ways. Calculate the total area of both rectangles and subtract the overlapping square. Or use transformation. Consider the shape as a combination of one full rectangle and one smaller rectangle. The answer is the perimeter of the shape is 36 cm, and its area is 65 square centimeters. Example 3, in the diagram, there are 6 squares. Each smaller square is formed by connecting the midpoints of the four sides of the larger square. Given that the side length of the largest square is 16 cm, find the area of the smallest square. We first seek the pattern of area changes. Observing the diagram, connecting the midpoints of the opposite sides of the largest square divides it into 4 smaller squares. Each of these squares is further divided by its own midpoint connections. From this, we conclude that each newly formed square has half the area of the square that directly contains it, following this pattern. Thus, the area of the smallest square is 16 times 16 divided by 2 for 5 times. We can get the answer is the area of the smallest square is 8 square centimeters. The key to solving this problem is identifying the pattern of area changes. Each smaller square's area is half the area of the square that directly contains it. Example 4. There are two squares. The side length of the larger square is 4 decimeters longer than that of the smaller square, and the area of the larger square is 80 square decimeters greater than that of the smaller square. Find the sum of their areas. Aligning the top left corners of the two squares and overlapping them as shown in the diagram, the total area of regions A, B, and C is 80 square decimeters. Since the area of region C is 4 times 4 equals 16 square decimeters, and regions A and B have equal areas, we find A equals B equals 32 square decimeters. Thus, the side length of the smaller square is 8 decimeters, and the side length of the larger square is 12 decimeters. Then, we find the sum of the two square areas. The answer is the sum of the two square areas is 208 square decimeters. This problem uses a constructive approach. By overlapping the two squares and analyzing their area relationships, we determine their side lengths and solve for the total area. Example 5. As shown in the diagram, 5 identical small rectangles are arranged to form a larger rectangle. Given that the perimeter of the larger rectangle is 44 centimeters, find its area. By carefully observing the diagram, we notice that the length of 2 small rectangles equals the width of 3 small rectangles. Using this relationship, we can determine the length and width of the small rectangles and then find the area of the larger rectangle. Since 2 times length equals 3 times width, we get length equals 1.5 times width. Using the perimeter formula for a rectangle, the large rectangle's perimeter can be expressed as 2 times length plus width equals 44 divided by 2. After substituting length equals 1.5 times width, we get 3 times 1.5 times width plus width equals 22. Therefore, width equals 4 centimeters, and length equals 6 centimeters. Now, we can calculate the area of the large rectangle. Alternatively, using the fact that the large rectangle is composed of 5 small rectangles, we can also find the area. The answer is the area of the large rectangle is 120 square centimeters. The key to solving this problem is the combination of numerical and geometric analysis. By observing the diagram and identifying the length-width relationship, we can set up an equation to determine the dimensions and solve for the area. Here are the practice problems for today. Thank you for watching and hope you enjoy your math today.